Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our presenters, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we'll be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is simplifying the developer experience, build and deploy from Docker straight to AWS. Our speakers today are Jonah Jones, who's a solutions architect at the AWS Partner Program, and Chad Metcalf, who is the Chief Architect, Cloud Alliances and Strategy at Docker Inc. Welcome, gentlemen. Thank you so much for joining me today. Really appreciate it.
Thank you.
Yeah, thanks for having me.
Yeah, you're welcome. Jonah, I know you're going to be kicking us off, so I'm going to take myself off camera, put myself on mute, let you guys get right to it.
Awesome. Well, welcome. Yeah, let's talk about simplifying the developer experience. So we will kick it off here. Maybe we can go over little introductions here. So I'm Jonah Jones. I'm a solutions architect for partners at Amazon, and I work with container partners. So I work with all the wonderful partners, including Docker, who is definitely our favorite container partner. I live in Portland, and previously I was a DevOps consultant at Amazon, and then I was a DevOps engineer before that in a past life. What about yourself, Chad?
Yeah, I'm Chad Metcalf. I have been at Docker for 6 years and working with AWS for I think the last 18 months or 2 years on this project that we're going to talk about today. So I'm super excited to talk about it and get people using it. I live in San Francisco, and previously I worked at both Puppet and Cloudera and a couple other startups, some on the developer side and some on the infrastructure side. So a little bit of everything.
That was a long time, 6 years ago though.
Yeah.
The world in containers, right?
Has changed.
Awesome. So when we're first talking about this container story, right, a lot of this drives from this idea of this innovation flywheel. And we hear a lot about this at Amazon, but it's probably worth talking about, at least as an introduction here. Again, this isn't going to be all like a marketing talk, so don't worry, guys. But it's definitely, as cloud, has kind of changed the landscape and companies are trying to move faster. This idea that you can experiment, get feedback, and then iterate on your ideas really fast has kind of been driving this whole new change, right? Like you can write code, you can immediately deploy it, know if it works or doesn't work, and then kind of re-brainstorm. Yeah, and I think this has kind of been a huge shift in the landscape, and honestly, a lot of companies are really trying to create these cloud innovation or these cloud excellence centers to kind of have this become a modern thing. Have you been seeing that, Chad, as well? That's something.
Yeah, it sort of came around, and people have always been trying to go faster, right? And when I first started at Docker, we would have these conversations with CEOs who had never heard of us, and they would stop us midway, and they'd look, I just want to go faster. How do we go faster? And I think that's this is part of it. And if you look at what Docker sort of enables with fast inner loops, and then potentially speeding up the outer loop, and then with this speeding up the deploy, that's exactly how you get it. You take out friction from each of these little steps, and then with that friction out, it goes faster. And actually, we did this for this experiment, right? So we didn't necessarily know 100% what it should look like. We didn't know how users would want it. And so we sent it out as a plugin, which is the fastest way to get a piece of Docker out to folks. I then got feedback and then iterated. So we're on our, I forget which release now, but probably our 8th or 9th big release of this. We have a couple more before we decided it's GA, but we've been getting lots of feedback from Docker folks, from AWS folks, from all of the users, and feeding that back in. And the only way you can do that is by having a fast response to change and getting the next version out quickly.
Oh yeah, I totally agree. Some of our services, like in the first year they launch, they'll have as many features as they have in the next 2 years combined, right? A lot of it's that quick innovation, and getting customers, getting customer feedback is definitely the way you get that for sure. Awesome. So like talking about getting this innovation flywheel, what does this look like in real life for us? Nowadays it seems like a lot of enterprises are going to containers, and that's kind of become like the toolkit to achieve this flywheel. And if you're not familiar with containers, they are a way to package application code and a neat little dependency object, right? So it has everything pre-compiled inside of it. It's portable to different machines. It can share an operating system with the host it's on, so it shares some of the components, such as like the Linux namespaces and the kernel. Yeah, they're pretty cool, right?
Yeah, I like to think of it like a literal shipping container. You just put whatever you need in the box. As long as it fits in the box, we can move it wherever, and like it's fine. Like every crane in the world knows how to pick this box up and put it onto a truck or a train or a boat. And so you tell me what trucks or trains or boats you want to use, and I'll move your box.
Yep, I've heard Docker's pretty good at containers. Is that true?
Yeah, we try.
We try. So
yeah.
Obviously containers are kind of all the hotness. So let's see, what are some of the benefits of using containers, right? I know you definitely hear some naysayers nowadays, but looking at some of the benefits, right? You can have your applications and dependencies defined as code. Super useful if you have rollbacks. It's easier to manage applications. You can standardize packaging and testing. Consistent implementation model, easier monitoring, that's for sure, because you can have something like a daemon monitor a bunch of containers on the system, and built-in versioning and security. Okay, that's all.
I mean, I think about it like you're wrapping an interface around the job that you do, right? So you can build containers so that you know that, hey, you put this plug here, you put that plug here, here's where your health check is, here's where your logs go, here's where this is, and then when it's time to go, you've got that. The other part is just, how many times have you either started a new gig or started a new project and you're like, well, now I need to go get started, and now I need to go read this wiki, and I need to go install a bunch of stuff, and I need to go get a bunch of different versions, and oh, the wiki didn't get updated, and so now I actually need to go get this other version that nobody talked about because nobody updated the wiki. All of that goes away. And that's sort of like, well, it worked on my laptop, why didn't it work on yours? That goes away. And I think from a developer's point of view, that's enough. Like, let's make your day-to-day job like easier. And then for the rest of it, yeah, there's all these other benefits, but like you can just start with like, let's make your loop better. And I think that's where a lot of developers start.
Oh, and it has made life so much easier. I recall about 5 years ago trying to install a LAMP stack on like a Linux server for the first time and doing all the commands by hand. And nowadays, I'm pretty sure you can have it up in less than 60 seconds with Docker, and not an hour, of running Linux commands.
Yeah, 100%.
Yeah, it's definitely. Also, I think security is worth calling out here. I think it has definitely changed the security game, because containers are immutable by default, and then there's you can do things like scanning before it hits. I think it made people step up their security game in a way, but it does feel like things have gotten more secure with containers, right? People are.
Yeah, I mean, in the very beginning of Docker, people would say, oh, it's less secure, but it turns out that it's more secure. So if you take a piece of software and put it in Docker, by default, Docker drops a bunch of Linux capabilities. So, like, what's Linux capabilities? If you take what root can do and chop it up, there's about 100 different things that root can do. And some of these things, for example, are like set the system clock. Well, why in the world would any application that me, a developer, write other than NTP need to set the system clock. And so by default, we drop about half of those capabilities out of the gate. So, you know, if somebody gets in and does manage to compromise, there's 50% less capability inside of that box than outside of that box. And so, you know, and NTP is a good example. Like, if you run NTP in a container, you have to add capabilities to that container by default and explicitly say, I want you to touch the system clock. I want you to load a kernel module. I want you to do these things. And you can't do that by default in a standard Linux container. And so, and you can also dial that down. So if there's other things you need to know that, like, you don't need to use network. Well, you can turn off the entire networking stack. And now how would anything bad happen in that box? Is literally nothing in there. And also, the only thing you actually need in the container is the application and its dependencies. You don't need anything else. Like, if you don't need a shell, don't put it in. If you don't need SSH or Telnet clients or any of that, don't put it in. So if somebody does get into that box, where are they going to go? It's a binary and some libraries. There's no shell to poke around. There's no utilities to help you find the next step. I think that's really changed it. And you get all of that for free just by using the tool.
Yeah, definitely. You're saying no shell, no SSH. It sounds like our bottle rocket release. We had some customers saying it was definitely a little difficult without the two, but it was meant for security, obviously, right?
Well, and developers could add layers to have that experience locally and then not have those layers when you go to prod. So I mean, there's lots of ways to make your local experience more comfortable and your remote experience more safe.
That is definitely true. I think Docker Compose is a great example of one of those. I know we'll talk a little bit more about that later.
And we'll show some making some differences between Docker Compose local and Docker Compose for prod.
Yeah, awesome. So when it talks about the benefits of containers, we have a few container services at Amazon that try to make the customer's life easier. Everything from our container registry, which can do things like security scans and be private, to our orchestration layer tools. So we have ECS and EKS as the different orchestrators. So these are the things that manage the container lifecycle. And then on them, there's different compute types. So it can be like a regular EC2 server, or you can use our serverless container option, which is called AWS Fargate, which can run on EKS or ECS. But the first one was on ECS, and it still has more capabilities. It's a higher Fargate platform version, so we consider that like the flagship Fargate when we talk about it usually.
Yeah, and I love Fargate because I just don't have to do anything.
Yeah, Fargate has definitely made people's lives easier. We found it that for all new customers that are going on to AWS and that choose containers, 40% of them are choosing Fargate out of the box. Obviously, EKS is very popular, but Fargate for new customers is the most popular service right now. So,
yeah, I mean, it's pretty simple, right? I want to run a container. Please run this container for me. I don't care about the rest.
Yeah, it definitely is really nice. I use it too when I got to get something up at up really fast. So. And then we have our networking layer. So we have AWS Cloud Map, which is what you can use for like local service discovery, and then AWS App Mesh if you want to get like a true service mesh going. And so back in 2015, this was the first container service we launched, Amazon ECS. And so this is really our first foray into container orchestration. It's being used by tons of companies. It's super powerful, can scale up to thousands of tasks, is deeply intertwined with all other AWS ecosystem services. I think that's like the biggest benefit of this over Amazon EKS is that if you use things like application load balancing or CloudWatch or Cloud Map, this ties super well into all of those.
Yeah, we'll see a little bit of that in later on the demo.
Yeah, definitely. So this has been around for a while, and it's what Fargate is launched on. And so if you use Fargate, you are actually using Amazon ECS. So you have to have an ECS cluster under the hood. And it's just a highly scalable, reliable solution. But obviously, we want to talk about the future here. So we're going to be talking about AWS Fargate. So the demo launch is on Fargate, right, Chad?
Yeah, well, so we create an ECS cluster for you, and then it goes into Fargate. and that's the default path. And we did that for a couple of reasons. One, because like you mentioned, it's much simpler. I don't have to think about like, oh, what AMI do I want to use, and if an update comes, how will I update that AMI, and all of those sort of like day two operational bits. It's not something that we wanted to tackle, especially for like a developer focused experience. But the other bit that we wanted to make sure is that this sort of elasticity of scale up and scale down was there, because at the end of the day, I want to be able to turn off my development environment or potentially turn off, what I'm experimenting on, and have that scale to zero and have that cost nothing, right? So other solutions might have management layers that have to continuously run, and those would have the meter still spin. And I think that's less interesting, like for a development use case. Like I just want to develop something and work on it. I might need more resources than my little MacBook has. Let me launch this somewhere. And taking care of all of that. And that was a great place for Fargate to come in. And then, like you said, it was integrated. So we have lots of folks that just want to use AWS. And so when we show this integration, we're going to show how it wires across. That's really complicated, and there's lots of value. So what we thought, both AWS and Docker, is that Docker can help do what Docker does best, which is take complicated things and make them really simple. And so you will get this like best practice Fargate with all of the sort of surrounding ecosystem of AWS pieces like CloudWatch and Cloud Insights and VPC, a security group tuned just for your application, but you won't have to know about that. And so that was the goal of this experience.
That's awesome. Yeah. And I think Fargate itself can be a little bit mysterious. There's definitely some stuff locked under the hood that we get asked about a lot, like, oh, is it expensive? It used to be when it launched, but nowadays it's actually the same price as an on-demand EC2 instance per hour. People ask about security, and so it actually uses a way that it can virtually separate out so that none of your tasks are sharing memory or CPU or disk usage with other people's tasks. And so, yeah, there's definitely a lot of mystery around Fargate, and they definitely kind of hide some from the user, but it's meant to, like, you don't need to know the guts. You just got to trust that it works.
Well, I think that's the value, right? Like, we all want to get our jobs done, and at some point you have to hand off chunks of work to other folks, because if you try to do everything end to end and you want this artisanal experience of like it's all hand done, you'll be able to do one thing. You'll be able to get one service running, and nobody has responsibility for just one service, right? Like a company has dozens, thousands of things, and so at some point handing that off. And also there's just a lot of complexity there that I heard somebody at AWS say nobody talks about undifferentiated heavy lifting anymore, because like it's just kind of just out there. Like it's not valuable to you or your job to do things like update operating systems or worry about those things. And then also, like you were saying, with Fargate being able to isolate like that, that's actually an advantage, right? So now you take a secure container and you put it into an even more, that's one of those security in depth, right? Like layering up security. So you take a secure container, you put it into something that's even more isolated than it was before, and you get an even better experience, and it didn't cost you anything. One of the things that I'll demo later, I didn't even know that Cloud Insights just worked. When I first ran this integration, it just showed up. I didn't ask for it. And so I think like that sort of like experience is what we're trying to accomplish in both of these teams working together.
Yeah, no, and you made a great point, like not having to care about certain things. Like if you had like a HIPAA audit or a PCI audit, right? Suddenly you're only responsible for what's in the container image. You no longer have to care about like the hosts in that portion of the audit. Like your life got a lot simpler for sure.
Yep.
Awesome. So what's next? Like, so what is this Docker and Fargate that we're talking about here? It's what people really came to see. You can take over slides here too, Chad.
Yeah. So we'll just talk about Docker just real quick, because everybody knows us as the cute whale company. So chances are you use Docker. If you don't, head to docker.com. I'll happily chat with you about what we do. We right now are laser focused on the developer and developer experience. And that's both individual developers and teams of developers. And so like, how do you onboard developers? How do you make that inner loop faster so that your development actual flow can go faster? And then how do you get a team productive and collaborating in a world where like the office environment has changed? And what does that mean when teams are collaborating in a different way? And how can Docker help make that better? And so what we're going to show today is based on some work that we did together. It's built into Docker, and it centers around Compose as a way to define an application. And so you might not be familiar with Compose. It's a way to define a container application and all its dependencies. So you can think of it as like A talks to B, B talks to C, and C just happens to be a database. And it has like every great tool, it has its own YAML format. It basically looks like this. So I'm defining a couple of services. I have a front end, I have a back end. There's some ports. The back end is needed by the front end. And so there's some complexity around ordering and things. But what people use this for, I use Compose a lot just to remember all the Docker flags. So like Docker run has a bunch of flags, and Compose can just take care of that for me. I also use it a lot for development environments. So like, hey, Jonah and I are working together this project. I'll just write a Compose file. Then we both can have a defined environment between the two of us that we can share these containers, these versions, these volumes, these secrets, these networks. And some people use it in production for sort of single host deployment. So what we do see is that lots of people use orchestrators, but a lot of people still actually just run bare engines and just launch individual containers or sets of containers on engines. And so lots of people do that through Compose.
Yeah, Compose is, I mean, if you see like a GitHub repo nowadays without a Compose file, and you're like, I gotta wire this all up myself to test this, you're probably just gonna close that right away.
Yeah. So I mean, it started with Dockerfile was like the common unit, and Compose became the next thing. So yeah, you find these in projects, and then I can just hit Docker Compose up like this. It's going to start the front end and the back end, and then the application is going to be up and running. And I don't need to worry about understanding all of the complexities of doing this. And then now here's the question. So I did that locally, and I want to go put that in AWS. And so I'm new maybe to AWS, or I'm just a developer that just knows little pieces of AWS. I've used some EC2 or something. And now I'm going to think about like, how do I get that into AWS? Okay, I think I need a VPC. I think I need an ECS cluster. Then that's going to be an ECS service. I'm going to have to create some task definitions. There's definitely going to be some IAM in there. I want an ALB because I'm going to expose a port. Definitely going to have to be some security groups. I'm going to want to deal with my logs. I'm going to want to have two containers be able to find each other. So I'm going to need service discovery. I'm going to definitely do some secrets because I'm not going to let everything just talk in the open. And potentially someday I want persistence. So before everybody runs too quick, persistence is coming, but we wanted to put this in here as an example of like, I need to go get all this stuff, and how would I go do that? That's a lot of stuff. And so solving that was really the goal for this this bit. And so we announced this, I think, in July or June, one of the J months. And we've been iterating on it since, but it's a native integration. So what you'll see today is you're gonna see Docker, and then Docker is going to talk to AWS for you on your behalf. And actually, we're just going to do Cloudformation. So we're going to take your Docker and convert that into AWS via Cloudformation and stand up native AWS stacks for you using Cloudformation. And then this just lets developers focus on their application, their development bit, right? So I call it the developer commute. If you think about the days that we used to commute, it used to be an hour for me to get to the office. I could do useful things. I could read books or listen to podcasts, but that wasn't getting my job done. And the developer commutes the same way. I have to go get a cluster. Well, that's time that I'm not actually developing. I have to go maintain this thing. That's time that I'm not developing. So what we're trying to do is shorten that developer commute, and also let you use familiar tools. Like you pointed out, lots of people know Compose, and there's Compose in lots of repos. With this project, potentially those files will just work, and they'll just go to ECS, and you won't have to worry about anything. Which I think is really slick. And the other bit is the part that really sort of put this idea in my head in the beginning, like 2 years ago, was this idea of context. And we'll show context a little bit more, but I just want to point Docker at the place I want the containers to go. I want them to go to my laptop. I want them to go to AWS, and context lets us switch those things.
Yeah.
And this was also just happened to be about the same time that we open sourced the Compose spec and took it out of Docker and made it its own standalone thing. And that was a good time to sort of make that part of this. And so,
yeah,
yeah,
you're talking about. Oh, sorry.
Go ahead.
I was just gonna say, you're talking about stuff that's slick. I think that, like you said, like, if you're a developer, oftentimes you don't know all of the services. And a great example is like AWS Cloud Map. That is getting used in this thing, and I bet most people on here have never actually used Cloud Map in production.
Yep.
But that's how they map up the wiring, so that, you know, when you're Compose, if you're calling Redis :80, right? Obviously, once I get deployed to AWS, that gets a whole new, CNAME, and that's what they use so that your applications don't have to be rewritten, so they can talk to each other using those same Compose URLs. And that's just, that's genius that's being done that way. It saves a lot of time for people.
Yeah, you know the tool that you know, and you want it to work, and there is complexity there, but we the tool owners like Docker and AWS, we can make that complexity go away for you. Not for us, but for you. So we are going to show this experience. I'm really excited that this experience is actually built into Docker now, as of the stable release we did about 2-3 weeks ago. So you're just going to type Docker, so Docker context use or Docker Compose up. You're not going to have to type a plugin anymore, which is what it was when this first launched. We use your credentials, and we just take that and use it securely, and we launch in with typical safe defaults. And you'll be able to use either the console to look at your applications or Docker command line, and I think both of those are pretty cool. This is an example application. It's not the one that we're going to see today, but what that looks like is we're going to pull images from Hub for a Nginx Golang application. So Nginx is effectively just acting as a proxy. Golang is on the other side. The developers are going to use their Docker CLI. So I do have the AWS command line tool installed, but I'm not going to actually use it at all. And I'm going to use the console only to show people what's happening. There's Docker Engine running locally, and Docker Compose on my desktop, and all of this is happening in the Docker desktop. So if you at home want to follow along, go to download Docker desktop, and you'll be able to basically have the same experience that we're showing today. We're going to use the ECS context. We're going to do a Docker Compose up, and it's going to go to Fargate and create this. And so this is just a quick screen just showing sort of some of that complexity we're talking about in terms of the Cloudformation standing up for you. And you can see exactly the service discovery bits are in there. There's a secret manager in there because we're going to do secrets. There's lots of different pieces and parts. I think, though, Jonah, it would be a good time to maybe have you sort of walk through the AWS side of complexity while I get ready to do this demo.
Yeah, for sure. And sorry about that ring you just heard there. Apologize.
Happens.
Yeah. So like Chad was just showing, there's a lot going on here, and it's all in Cloudformation. It launches really fast too, so it makes you think that there's not a lot of resources, but there are. So it will map the applications from your Docker Compose. It will create the ECS task definition, the service, and the cluster. And it will launch these inside the VPC. It will create a VPC for you, right? and launches them as Fargate tasks. So they are all isolated by themselves. You don't have to think about any EC2 instances or auto-scaling groups at this moment. And then it comes with some really good best practices. And this is, I think, where this plugin shines, right? A lot of people can launch a EC2 instance and install Docker and get something up and running quick, but it's really not done well always, right? Quick and well are not often synonymous when it comes to like POCing stuff. So this is launching security groups that are actually mapped down so that like service A can only talk to service B. It comes with CloudWatch logs. The log group's already like pre-done so that it will launch the application load balancer with all the correct routes and security groups. It will launch the correct scope down IAM roles, cloud map for service discovery so you don't have to rewrite anything. So it is doing a lot of really smart stuff under the hood and also like best practice security wise. And so that's kind of what's happening in AWS land. It also has the ability to pull from Secrets Manager and pull images from ECR. So it does have some other native tie-ins there if you choose. And obviously, we get to see a sweet demo of this.
Yeah, so let's keep chatting about this while I figure out why it's not letting me log into AWS.
Of course, yeah. I think one thing that you kind of hinted about earlier was the EFS volumes, right? I think that these are actually a huge thing and so when we launched this plugin, a few months ago, that has been the #1 issue that's been upvoted is the support for EFS volumes, right? If you're developing locally, if you use Docker Compose locally, you probably use volumes. It's kind of the standard thing nowadays to have some sort of persistence. So you're not having to rebuild the containers and get all the assets back in. It's super useful if you use certain type like coding languages, right? Like if you're using JavaScript or Python, things that you don't always have to pre-compile to like a binary. And so what we have heard is that like people want volume. So there's a new feature coming out, which is EFS support, so that you can actually get an EFS file system that will be mounted, and then it can connect from your local computer into the cloud. So you can have some sort of data persistence. So if you spend down that stack, that Cloudformation stack at the end of the day, and you launch it back up tomorrow, you can have all that data mirrored from your computer to the cloud, right? And so that's kind of like no data is lost if you're actually trying to use this in production, and that's super useful. We're just talking about EFS volumes. I know that's like the #1 thing people ask for, so.
Yeah, so, two-factor authentication is everybody's favorite thing. And
yep.
Luckily, this is now working. So I'm going to switch over to this demo. So let's.
And just for the audience out there, so Docker Context is using the same sort of like AWS profile behind the scenes as like our AWS CLI. Is that correct?
Yeah, and we'll actually see some of that in this. So
okay.
Hopefully.
So it's not sort of some black magic. It's using basically the same way you authenticate as your CLI.
That's right. So hopefully you can see my screen. I'm going to go to the simple Flask app. Let's see what I got here. Some differences. Let's just see what I've got real quick before I go do something crazy. Oh, this will work. This is fine. So what we have is we have a Flask application. It is. Oh, that's weird. We're going to grab a secret because we're going to connect to Redis. It's not ideal to print secrets, but I'm just printing it just to show that it's there. We're going to go to Redis on the back end, and we're going to grab on a port, and we're going to use this password. The application itself is very simple. On a page load, it pushes a timestamp into Redis and then renders out a web page with all of the timestamps that were in Redis. And so it's pretty simple, straightforward. If we go look at the Docker Compose file for this, there's two services. There is a front end, which is coming from Hub. It's got a port. We're using a database secret. It depends on the back end. The back end is just Redis. We are using the password to set up require pass. This isn't probably the best way to do it, but for the sake of this demo, it makes it really simple. But you do want, you are going to want services to use things like passwords, and so this is a good easy example to see what's happening without having to do a bunch of configuration management to like put it into the right conf file on a disk. And then we're going to use a secret. So if we go look at that secret, it's on disk. We could also create this secret in Secrets Manager and just use that's already there. But just for a sake of a demo, I'm going to use this super mega ultimate secret locally. And let's look at what happens for these two. You'll notice I actually have 3 compose files. I have Docker Compose dev, and Docker Compose prod. So we looked at Docker Compose. Now let's look at what I want to change for dev. So what I'll do is I will run Docker Compose, and I will give it the Docker Compose YAML, and I will also give it this Docker Compose dev YAML. And what that'll do is it'll override a couple of things. So instead of using an image, we're going to build out of a directory. We're going to add a environment variable, and we're going to use some additional volumes. So I'm going to use a volume for the code, which is going to enable live reload. So if you've got like a Python app or a Node app or something that supports live reload, where you can have your IDE up, you can make changes, it'll detect those changes and automatically reload your application, you can do that. And so that's what I'm doing here. I'm basically mounting my local code into that container. And then for the backend, I'm gonna store some data for Redis persistently, so that as I iterate over this and like up and down it, I will have data that sticks around. It won't just get tossed. And let's just, for sake, see like, well, that's dev. What are you doing differently in prod? And for prod, I'm going to do 2 things. I'm not going to change the backend at all. I'm going to use an environment variable to get the front end image, and I'm going to add this extra xpull credentials bit, which is a secret in Secrets Manager that tells ECS how to go get those images from Hub. And so I don't need that locally, but I will need that in ECS, because ECS can't see my local image cache. So
so this is using a private Docker Hub, right?
That's right. It's using a private Docker Hub. So I'm going to use make to type some of this stuff for me, but let's just go see what these commands look like. So when I type make dev, what's going to happen is it's going to do this. It's going to use the CLI to do the build. We're going to do Docker Compose with 2 files, the Docker Compose file and the dev file, and I'm going to say up and also do the build. The build is going to use these contexts, which we'll talk about a little bit, but ECS can't do builds for you right now. And so you have to build locally. So because I have multiple contexts, I just want build to always go to the default context, which is my local Docker. You could push this to ECR. This example will be available for everybody who watches this webinar. It'll be on GitHub. We'll send out the links. And so if you want to send this to ECR, you can. You can also send it to Hub. And then the deploy, we're going to set the environment variables to get the secret and the front-end image. And then we're going to do Docker context ECS compose up with basically those 2 files. Take the base file and then put the prod extensions on top and up it. And we'll see that as well. But I just wanted to, I'm going to use make to type it all, because this is just a lot to type, but it'll all be here for you to see when you see this example. So here's what a pull secret looks like. It's the ARN for the Secrets Manager for that. And here's what our front end image it's going to be. It's going to be Metcalfe timestamper with the current Git tag. And so that's all in there. So if I do make dev, Oh, go ahead.
So that volume you created, that's getting turned into a AWS Secrets Manager secret, right?
So this secret right here will get turned into a Secrets Manager secret.
Okay, awesome.
And
So that would
so
be in the Cloudformation then.
Yep. Yeah, and you can see this in, oh, sorry. You can see this if you go to Docker secrets and then do Docker secrets list. I can see that's the hub secret. And then when I do up for this, it'll show that. Actually, a good way to do that would be to look at Docker compose convert. Here's the CloudFormation for the stack that we're about to deploy. And so somewhere in here here's the mount point for the secrets. Here's the log configuration. Here is this is some of that service discovery bits that you were talking about before. Let's see, where is the actual secrets manager? It's in here somewhere.
So this is super cool. And so I'm guessing the IAM role is getting scoped down to only have access to that one secret, not all Secrets Manager secrets, right?
That's two secrets. It's got the push secret and the secret for the actual secret that I'm creating. But yeah, it's all in here. And actually the security group is also scoped down. So we don't have to tell the front end that it can talk to Redis. The security group takes care of that. And then the security group also takes care of the fact that the front end is the only thing that exposes a port, and that it's on 5000, and that the load balancer can take care of that. And so all of that's just wired in for you, and you don't have to know any of the specifics around that. So let's get this up on dev and see what happens. So we're going to do make dev.
Yeah.
Oh, so this is a good example. So I tried to do something locally, and I was in the ECS context. So if you see over here, my little whales telling me what context I'm in, my little Moby. So I want to go back to Docker context, use default. And now I want to do make dev, which is basically build it locally. And so it's going to go ahead and build it and then run it. And one of the things I love about compose logs is that they stream interleaved and then tell you which of these things it is. So this is the logs from the back end. This is the logs from the front end. You'll see that it picked up that development environment variable and launched on a port for us. So let's go see what localhost 5000 looks like. And what you'll see is there's some existing data in here because I've been working on this demo since September 26th. And so we can add some new timestamps now and get some new data. So here's the 30th, and we'll just see that. And if we go look at the logs, we're seeing the timestamps come scrolling by. And so, oh, and here's that not ideal to print secrets, super mega ultimate secret. And so we see the secret actually showing up in both of the apps. And actually, the fact that the app can talk to Redis at all is showing that that secret's done. So that's local though, but I want to do that same thing, but send it to ECS. So that's where the magic comes in, because there's really very little difference. So I'm going to do a couple of things.
So will this app be public? So can I go click these timestamps once it launches?
Yeah, when it'll be a long URL, but you'll be able to go click it.
Perfect.
And actually, we can leave it up for a little bit, and anybody in the webinar can go click it. I'm going to do a real quick make build just to make sure I've got the latest and greatest, and I'm going to do a make push, which is going to push it to Docker Hub. Oh, sorry, push Hub. And just so everyone sees it, that's just this is the command that it ran. It's just Docker context default push timestamper. And then the reason I had to do that is that I'm about to try to run something in ECS, and ECS can't see my laptop. And so I have the image here, but we need it there. So now let's do make deploy. And this isn't going to work because I'm actually in the default context still. I need to switch. So Docker context use ECS and we'll do make deploy. Oh, so I actually made deploy also do the push because I always forget to do the push. So it just pushed it again, but there's no problem in pushing an image multiple times. It's already there. This is my favorite user interface right now because the old one, it would just scroll by and you never knew what was going on. This one, we're seeing all of the CloudFormation happen and timing how long it takes. So this takes about 4 minutes on average. Sometimes it's longer, sometimes it's slower. It's almost always the load balancer that wins in terms of the thing that takes the longest to spin up. But if you think about it, it's going to be kind of magical because in 4 minutes, we're going to have an entire application and an entire container stack up and running in AWS, and I didn't do anything. So while that's happening, let's go back over here and go to the console and just check some stuff out. So let me make this a little bit bigger for y'all, and we can go look at CloudFormation.
And you can bring your own load balancer if you want to speed that up too, right?
You can bring your own load balancer, you can bring your own VPC, you can bring your own ECS cluster. We do have customers that, like developers, they don't have the rights to make those things. They have like a centralized team. That centralized team can give you the IDs for these things, and then you can tag it in and it'll just work. So here is the Docker Simple Flask, and here is the stack. And we can see all the resources that are being created on my behalf. We get links to them all, but this is just a CloudFormation stack. And so, you know, if you've got teams of developers doing this, you'll be able to, you know, see the stack, see who's responsible for the stack, see what's in the stack. You know, I'm sure there's lots of people who care about billing and tracking billing and understanding that. And so all of these resources get bundled under one way to see it, one way to manage it, one way to understand who's using what and doing what. So it's a pretty slick way to go. But we can jump into some of these things just to go see, like, let's go see the security group. We talked a little bit about the fact that it does some magic for us. So let's look at inbound rules. We're going to allow 5,000 because that's what the application exposes. And outbound rules, you can all traffic to the outbound. And then also, I think this is allowing the containers to talk to each other. So communication within the network. So within basically anything in the stack can talk to each other. But that means that outside of that stack, you can't talk to it. So the only way to talk to this thing is to come in through the load balancer.
And that 5,000 is only because the port 5,000 was exposed in your compose, right?
That's right. And I didn't have to tell anything besides expose port 5,000. So if we go back to the command line just to see where it is, the load balancer's up. The last thing we're waiting for is the front end service. So let's go look at maybe just, let's go look at the backend service because it is up already. So we can go to services, we can go to ECS. We go to Simple Flask. Looks like the backends or the front end's just about up. It's not quite running, but it's almost there. We can go look in the tasks. And so here's the task that was running. We can drill into those tasks. We can see the logs for that. We could go to CloudWatch and just watch the logs there. And these logs are the same logs as you would see in the command line. So while that's still running, actually one of those details that people talk about is this is actually the task definition for the backend service. And so you'll see all of the pieces in here. So like we want to use this mapping, we're going to use this secret. And so task definition is actually it's a very powerful but mildly complicated schema. And so you don't have to know a task definition. We will create one and then update it for you. We're not going to do an update today, but with this, I could go make a change and do Docker up, and it would go update the task definition and then do a blue-green deploy for me of that new service. And I don't have to know anything about updating task definitions or setting up blue-green deploys or anything else. which I think is really slick. So that has come back. So now I could do Docker compose logs.
I love this. These look so
And
awesome.
it's the same experience. It's the same experience in the same spot. It's still not ideal to print secrets, and it's still the same secret. If we go do Docker secret list, we see two secrets. We see the database password secret and the hub access token secret, and both of those were created and managed for me. And so now let's see where this service is. Docker compose.
Those logs you just string, those were straight from CloudWatch, but it looks like it's Docker compose, right?
That's right. It's straight from CloudWatch, and you can actually tail it. So if the logs come in, actually, let's do that. Let's do Docker compose logs. I think it's F for follow. Wait, hold on. Let's see, what is it? Maybe I don't need to do it. Maybe it just works. Docker compose logs. Oh yeah, it's just going to tail it by default. So what I do need though is I need this. So I did a Docker compose PS here, and we got this, the two services that are running, and this one included the port to go talk to this thing. So on port 5000 at this URL, and I'm going to go back to this and go here, and now it's up and running. So this is a long total, like entire audience. I'll just go ahead and drop something to the entire audience. Like, y'all can go to that URL, and if you want to, you can timestamp it. We probably see a bunch of timestamps come in. So I will jump back to this terminal and drop this down a little bit. So I'll timestamp it a couple of times. Oh, there's definitely some timestamps coming in now. So there's some folks that are clicking it. Okay, so there's a lot of folks. Let's go ahead and reload this and see. Yeah, there you go. So I definitely didn't click the button that many times. People in the audience are clicking the button. So that's a cool one. That's a new one. We haven't done that on this thing, but yeah, keep cooking and we'll see more and more data come in. But that is sort of the power. So from I made a change where I got an application up and running to I decided I wanted to put it into Amazon, and that was 10 minutes. So we're almost out of time for questions, so we should probably jump to questions real quick. Maybe we can get one. But there's going to be more questions than there is time to answer. So Jonah and I are going to do a live stream on Docker's YouTube channel. So if you go to youtube.com/dockerrun and subscribe, in 2 weeks we'll be back online to do basically all the questions that we couldn't answer here. We'll do it there. So join us on YouTube in 2 weeks.
Excellent. Okay, yeah, we've gotten some questions in. I'm going to try and get one, maybe two in over to you guys before we before we run out of time. Here's one. What is the connection between AWS Fargate and AWS, SageMaker Studio? Is there one? We've stumped our panelists.
Yeah.
So SageMaker is an ML, right? It's a machine learning thing.
Yeah. Let me give you like 1 minute. I can try to get you an answer here.
So let's do another question and see if we can.
Okay.
We'll come up with a quick answer.
Okay. All right. How do I get context environment ECS on my Docker?
Oh, so you're gonna go get Docker. And then you're going to do let me reshare my screen. You're going to do a Docker context create. And in here, you'll be able to create an ECS context, and it will walk you through you need to give it a name. So Docker ECS create new ECS, and it'll walk you through. So in this case, I have a bunch of profiles. I'm gonna use this profile. Yeah, sure, US West 2 sounds great. I don't want to enter my credentials, and there we go. And now I have a new context up and running. So
Cool, 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 cool.
So back to, I don't think that there is any relation between SageMaker Studio and Fargate. And I say this because SageMaker Studio has no cost. And so typically Fargate does incur a cost. So I think it's just one of the provided UIs for doing machine learning.
Excellent. Okay. All right. Let's try to give you guys one more question and then we'll wrap it up. How do you tell your deployment to use your existing resources, such as subnet, security groups, load balancers, etc.?
yeah, that's a good one. So if you go to docs.docker.com and search for ECS, the docs are in here, and it talks about how you can override a number of things. So if you want to change how the blue-green deploys work, or use your own policies, your own IAM policies, or use your own clusters, or use your own VPCs, load balancers, all of that's available for you. So go to docs.docker.com and search for ECS, and it will be there.
Excellent. All right. Well, we're about 4 minutes to the top of the hour, so I'm going to go ahead and close out the question and answer period. But as you guys said, you're doing a live YouTube events later, so where you guys will have all of these questions to use during the live event, correct?
Yep. So youtube.com/dockerrun, and join me and Jonah. We'll have these questions plus whatever the audience wants to do, and we'll do that in 2 weeks on Wednesday. So Wednesday, 2 weeks from now.
Excellent. Excellent. Okay. So anybody who didn't get your question answered during today's event, tune into that, and they'll get to your question at that point. Also want to remind the audience real quick that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. We will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can go look for it there as well. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, also, I mentioned at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. So let's go ahead and do that real quick. Our first winner is Alejandro G. Congratulations, Alejandro. Our second winner is, let's see, Blanca N. Congratulations, Blanca. Our third winner today is Nate M. Congratulations, Nate. And our fourth and final winner today is Stephanie S. Congratulations, Stephanie. We'll be following up with all 4 of you via email to get your Amazon gift card over to you. So check your inbox. If you don't see it in your inbox, please check your spam folder. Do want to thank again all the audience for submitting questions, so many great ones. And as we said before, these guys do have a copy of them all, and so tune into their next event in a couple weeks, and hopefully the question will be answered at that point. And I do want to thank Chad and Jonah for joining me today. Great presentation. Lots of fun to see the demos. I know the audience gets a lot out of it. I do too. I think they're tons of fun. So thank you both very much for your time and your expertise. Really liked it.
Thank you.
And I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.
Yeah, thanks. It was a pleasure. Have a good one.
Bye.